So in this problem, I want to take this vector f and decompose it into components in the e hat 1 and e hat 2 directions that are defined like that. So if you follow my recipe, what we do is we take this vector f and we construct a vector triangle from it. So f is going to be the hypotenuse of the triangle, and what I want to do is I want to write this vector f as the sum of two other vectors, and these two other vectors are parallel to the e hat 1 and e hat 2 directions. So in particular, in this case, I've got this one vector in the e hat 2 direction, like so, and another vector in the e hat 1 direction, like so, and when I add those two vectors together, I get the vector f, the original vector f. And all I have to do now is figure out how much in the e hat 2 and how much in the e hat 1 this is. So somewhere in this triangle, I have to identify an angle to an angle that's given. And the easiest way for me to do it is maybe just do a little example here. So let me just draw a horizontal line right there. And we know, by the way it's given right here, that this angle right here is theta. And if that angle right there is theta, then this angle right here is theta as well. And this angle right here is the same as that angle right there, right? Because, you know, this e hat 1 component right there is a tangent to that line there, and that f is horizontal. So this angle right here is theta. So therefore, since the e hat 1 component, this is the component parallel to the e hat 1 direction, it has magnitude f cosine theta because it's the side adjacent to the angle. And then the other side, the one in the e hat 2 direction, is the sine f sine theta because it's the opposite. It's on the opposite side of the angle. Okay, now finally we need to get the signs right. Notice that this e hat 1 component of my vector, it's in the opposite direction as the e hat 1 basis vector. So this component of f should have a minus sign right here because, again, it's in the opposite direction. And likewise in the e hat 2 direction, look at this thing. Here's my component of the force. It's in the minus e hat 2 direction. So that's why I put the minus sign right there again. And that's the way it works. And hence, here's the answer again. Now, one thing worth noticing that when I drew my force triangle, I did it this way. I started at the base of f, and I first went in the e hat 2 direction, or actually the minus e hat 2 direction. Then I went in the e hat 1 direction. Now, I could have gone in the e hat 1 direction first. It's perfectly fine. So in other words, I could have gone this way first, and then that way. And if you do, you'll find you get the exact same thing. In that case, this will be the angle theta in that triangle, and you'll get the exact same trigonometry.